Today we will be finding the volume by integration using the dishwasher method and the shell method. So you can use both methods to solve a problem and you will have the same answer. So we have this problem: find the volume bounded by the equations y is equal to the square root of x and y is equal to 1/2 x rotated around the x-axis. So this curve is your y is equal to square root of x, and this straight line is y is equal to 1/2 x, and it is this one will be rotated around the x-axis. So I will be using both methods, first the dishwasher method and then the shell method, to show you the differences. So in the dishwasher method, the difference between the dishwasher method and the shell method is in the way that you slice the area and in finding the volume. So this is the area of the bounded by the two equations. So we will first discuss the dishwasher method. So I'll just rewrite that drawing. So it will be like this, and then it will be like this. So this is the area. Now in the dishwasher method, the slicing is perpendicular to the axis of rotation. So this is your axis of rotation. So this is your axis, and the slicing, the cutting, is perpendicular. Whereas in the shell method, you will slice it in the parallel to the axis of rotation. So this is your drawing. This is your axis of rotation. You will cut it in this way. So in the dishwasher method, you will cut it this way. Now, so let us try to rotate. So if we rotate this one around the x-axis, so this one will also be rotated. It will be looking like this. So it will be looking like this. Not a good drawing. So it will look like a washer. So this is an example of a washer. So if this drawing will look like a washer. So I have exaggerated the thickness, but it's supposed to be very thin. So we slice it perpendicular to the axis of rotation, and it will look like a washer. So we want to get the volume of this washer and then integrated it from here up to the end point, to the point of intersection. So we can have the volume. So it's like a bullet, and then it has a hole that is funnel shaped, triangular shape. So that will be your volume. Now first what we need to do is to find the point of intersection, so we can have the limit. We know where to stop when getting the volume. So getting the point of intersection, so we equate, as in my previous video, to find the point of intersection, we equate the two equations, and then we can find the x. So y is equal to square root of x equated to y is equal to 1/2 x. You will have square root of x is equal to 1/2 x, or x over 2. Squaring both sides, to remove the square root, we have x is equal to x squared over 4. Now, multiplying 4 on both sides, we get 4x is equal to x squared. We can swap it around. We have x squared is equal to 4x. So if we want to equate the right side into 0, subtracting 4x on both sides, we have x squared minus 4x is equal to 0. And then we can factor out x. We have x minus 4 is equal to 0. That's 0. So we have to equate this one to 0. We have to equate this one to 0 so that this will be 0. So if this is equated to 0, your x will be equal to 0. And then if x minus 4 is equal to 0, x will be equal to 4. So your point of intersection will be this point. X is equal to 0, and then we know now that this one is equal to 4. X is equal to 4. So that is your point of intersection. Let me erase this one first. Now, so we have 4. So we want to get the height of this one. So equating this one into either here or here, we can get the value of y. So if using this one, y is equal to let's use this one. Y is equal to 1/2 of x, which is 4. So y is equal to 2. So this one is 2. So your point of intersection is 4, 2. So you know now that the height is 2 and the length is 4. Now so we can proceed. So using the disquassion method, the easier method is to find the volume of that bullet-shaped solid, and then we subtract the hollow part of this shape. So we don't have enough space. I'll just erase this one. So we have. So what we will have is. So first compute the volume of the whole solid. So let's say this is this is supposed to be connected. So let's say now. So we have to find the volume. We find the volume of this one, and then we subtract the volume of the hollow part of this shape. So we subtract the hollow part. So this will be the hollow part of that, and then we can get the volume of the shaded area. So so we can use the disc method. So if we get a slice, a small slice, and then this is your slice, this is your thickness, and then we rotate it around. It will be looking like that. So this is your y, or your radius, and then this is your dx. The thickness will be dx. So we want to get the volume of that disc. So I just want to show you the disc. Here's an example of the disc. So this thickness, the thickness will be the dx, and this circle is the whole circle, where the radius will be from the center to the edge of the circle. So the volume of that disc will be equal to the area of the disc multiplied by the thickness of that disc. So the area is pi r squared. multiplied by dx. So the volume will be pi, so what is the radius of this? So the radius of this is the value of y. So the value, your radius will be y, which is this one, and that's the square root of x. So the area is pi r squared. So instead of the radius, we substitute the value of y, which is square root of x squared, pi r squared. So this is your area of the disk. And then we multiply that with the thickness. So that will be the volume of this disk only. Now, but we need to compute it from here, from 0 to 4. So we need to integrate that from 0 to 4. So that will be the volume of the whole bullet-shaped pattern. Then we subtract the volume of this cone, which is the hollow part. So it's, again, we minus. So this will have another disk. So let's say this is the disk again. So again, this is your y, but this time your y is equal to 1/2 x. So the volume of this one is pi r squared. So pi r, your radius will be your 1/2 x, pi r squared. So pi 1/2 x. This is your radius. So pi r squared. So we square it, and then we multiply it by the thickness, dx. So this is dx. That's the volume of this disk. But since we have to start from here to here, which is from 0 to 4, so we integrate it from 0 to 4. So now the square root of x squared will become x. So this will be pi. So pi x dx. Yeah, I think it's easier to rewrite to avoid confusion. So the volume from 0 to 4, pi x dx minus 0 to 4, pi. So this becomes, if you square this one, this becomes x squared over 4 dx. Now, so if we integrate this one, this x becomes volume is equal to, so we can separate the pi because it is constant. So let's separate it. So let's put it on the left. And then x, if you integrate x will become x squared over 2. So that's your integration of x. And then we evaluate it from 0 to 4. The same thing goes in this one. So we separate pi. If we integrate this one, x squared becomes x squared over 4 becomes x cubed over 12. So 4 times 3 will be 12. Then we evaluate it from 0 to 4. Now, so we substitute x from 0. We substitute the x with 4 minus x substituted with 0. But since this is 0, we just change it with only 4, and same goes with this one. So this becomes volume is equal to pi x to the fourth 4. So this becomes 4 squared over 2 minus pi. So we substitute 4 to x as well. So 4 cube over 12. So I did not include the 0 on both parts. Taking out the, so we have a common factor pi. So we take out pi. We have 4 squared over 2, which is 4 times 4, 16, divided by 2 is 8 over 1 minus, so 4 cube is 64, 4 times 4, 16 times 4, 64 divided by 12, reduced to lowest term, it will be 32 over 6. So this is more algebra now. So, but in summary, your volume will become 8 pi over 3. Now we go to the shell method. So in the shell method, like I said before, the cutting is parallel to the axis of rotation. Now we will just copy the drawing. So it will be like that. So this is your, yeah. So this is your, so we cut it this way, and then we rotate it this way. So the cutting is, it looks more like a finger, a ring. So I just write this one. So make it bigger, make it easier to understand. So you have here, and then you have the, I will exaggerate the curve. So this is your curve. Oops, it should be in the 0 anyway. And then we just do a similar one on the other side. So this is your volume. Now we cut it parallel to the axis of rotation. Now and then we rotate this one. Now I'll just separate the shell, so the cylinder, so it will be looking like this. So that will be your shell, the slice that you want to get the area. Now, if you will notice, this is a, it looks like a cylinder with open top and bottom with a hole in the middle. So we want to get the area of the surface area of a cylinder. So imagine this is your cylinder. So to get the area, you need to get the here's a piece of paper. So what you have here is, this is like this one is like this. So it's like a shell of a cylinder. So this is your cylinder. Now you want to get the surface area of this one. You don't need to get this. So the surface area of a cylinder, you need to get the area in here and here. But in this case, we only need to get the area of this one. So how to get the area of this one? If we open it up, so we can get the width and the height. Now the height of this one is equal to the circumference. The height of this cylinder is equal to the circumference multiplied by the thickness. So it's like this. So the area will be the circumference multiplied by the thickness. So what is the formula for getting the circumference? So the circumference is equal to 2 pi r. Now in this case, this is our cylinder, so your r will be your y. So your y in this case will be this. Y is equal to 1/2 x. This is your y. Now, so we can subtract, you can substitute r with your y. So circumference will be 2 pi y, and then we multiply by this thickness, and this thickness will be, so this thickness will be let me rewrite this one again. So from here to here, I just want to rewrite this one again. So this is your curve, this is your thickness. So your thickness will be from here to here minus, so this is your thickness, this one minus this one. That will be your thickness. And now this length from here to here will be your, so this one, this will be your XR, your X to the right, minus this one, so X to the left. Okay. So what is your XR? Your XR will be, so we find the value of x in here. So to get the value of x, so y is equal to 1/2 x, multiplying both sides by 2, you get x is equal to 2y. So your XR will be 2y, and then your x left will be this one. Y is equal to the square root of x. So squaring both sides, you have x is equal to y squared. So your XL will be y squared. So what is your thickness now? So your thickness will be XR minus XL, which is XR is 2y minus y squared. So this is now your thickness, the thickness of your shell. So this is your shell. Now the thickness, this is your thickness, this is XR minus XL, which is 2y minus y squared. And then multiplied by the length, which is equal to the circumference, which is 2 pi r. Okay, so let's we can now solve for the volume. The volume would now be, let me clear up this one first. So the volume is equal to the circumference, so 2 pi y, so 2 pi r or 2 pi y, which is the circumference multiplied by the thickness of your shell, which is 2y minus y squared. And then the thickness of this one, so you have to multiply that area, that the surface area with the thickness dy to get the volume of that shell. Now, so we have to slice, so this is just one slice, so we have to have infinitesimally thin slices. So that is from 0 to 2. So we have to integrate that from 0 to 2. So basically this is your shell. This is your shell. Now so you multiply this one, so this is your shell, this is your circumference, which is 2 pi y. So if we spread it out, this length is 2 pi y. We multiply it by the thickness, this one, so 2y minus y squared, this is this one. And then dy is the thickness. This one is dy, the thickness of this paper. So this is we need to compute for the volume of this sheet. So once we get the volume of this sheet, we have to get the volume of these very small sheets from 0 to 2. So we evaluate it from 0 to 2. So now we get to, so we can now proceed. So this is so since 2 pi is a constant, we can take it out of the equation of the integration. So 2 pi, we can put it here, and then integral of from 0 to 2 of y multiplied by 2y minus y squared dy. So we can now so this is y, so we can multiply, we can distribute y. So what you have is 2 pi, the integral of 0 from 0 to 2, 2y squared minus y cubed dy. So if we integrate 2y squared, so 2 pi, if we integrate 2y squared, this will become 2y cubed over 3, and then if we integrate y cubed, this becomes y to the 4th over 4. So we integrate it from 0 to 2. Now similar to this one, so we substitute 2 into y and then 0 into y, but since this is 0, both will become 0, so we just substitute 2 to this one, So this becomes 2 pi. So 2 times 2. So we substitute now 2 in y cube over 3 minus, so y to the fourth becomes 2 to the fourth over 4. Now this is mostly algebra or arithmetic, so this becomes 2 pi. So 2 times 2 times 2 times 2 is 16 over 3 times 2, 4 times 2, 8 times 2, 16. Yeah, 16 over 3 minus, so 2 to the fourth is 16 to the fourth, 16 over 4 or 4 over 1. As a shortcut, this becomes 8 pi over 3. I can continue this one. This is mostly arithmetic anyway. So they will have the same answer, but the method of slicing is different. So that is the dishwasher differentiated from the shell method.